Today we will discuss in mathematics the terms set, relation and function, which is the fundamental of mathematics. Now first of all we know about set. What is set in mathematics? Set is nothing but it is the collection of objects. More precisely we can say that collection of well-defined objects. Collection of well-defined objects is called set. Now, what is the meaning of well-defined? Here we tell you the meaning of well-defined. Well-defined means we are able to determine whether an object belongs inside that set or not. Now, subset of any set. Let A denote any set like A equal to x belongs to natural number such that x is less than 10, then A equal to 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now, if we collect some elements of A or all elements of A, then becomes another set. Suppose B. B is nothing but this is the sub collection of A. Suppose we can take 1, 2, 3, or we can take 1, 2, 4, or we can take 1, 2, 5. Means it's our choice what element we want to choose from A. Then the set B is called. Then the set B is called subset of A. Then the set B is called subset of A. Now it is very important to know about how many subset can be formed from a given set. How many subset we can form from a given set. Now my another article is number of subsets from a set let cardinality of A equal to n. Here we write cardinality of A means number of elements projecting inside the set A. If set A contains n element like A1, A2, an, then if you want to form the subset from A, then each element of A have two choices. Either we can take A1 inside that subset or we cannot take. A2 have also two choices, An also have two choices, means each element has two choices. Here A1 have two choices, A2 has two choices, An also have two choices. Total number of choices 2 into 2 into 2 2 total n combination means 2 to the power n. Hence from any set A which cardinality is n, we can make exactly 2 to the power n subsets. 2 to the power n subsets. We also know each set is subset of itself and phi is also a subset of itself. We can take an example. Like if we take A equal to 1, 2, then number of subsets of A equal to number of subsets of A each equal to 2 to the power n means 2 to the power 2 equal to 4. Namely 5. We know 5 is the subset of each set. Singleton A, singleton 2, 1, 2. These are 4 subsets of a given set A. So these are the sets and subsets. Now we know about power set of a given set. What is the meaning of power set of a given set? Now we define a term power set. Power set. Let A be any set, then collection of all subsets of A. Then collection of all subsets of A is called power set. Power set. Suppose cardinality of A equal to n. Then number of subsets of A equal to 2 to the power n equal to cardinality of power set of A. Here power set of A, P of A denotes the power set of A, that is all the subsets of A. Collection of all the subsets of A. Means if we know the cardinality of any set, then we can tell about the cardinality of power set. So this is the power set. Now we define Cartesian product of two sets. Cartesian product of two sets. Cartesian product of two sets. Let A equal to 1 2 and B equal to AB. Then their Cartesian product is defined as A cross B equal to 1A, means that the collection of ordered pair type number 1A, 1B, 2A and 2B. We can take any member, any set A and any set B. We can find their Cartesian product like this. With the help of Cartesian product, we are able to define the term relation. Relation is very important in mathematics. Now we define relation. What is relation with the help of Cartesian product? Relation. Let A and B are two sets. Then yes, which is a subset of A cross B, is called relation. From A to B. It's called relation from A to B. Means all the subsets of A cross B is a relation. Now we are determining how many relations we can form if the cardinality of the set A and cardinality of set B is known. Now suppose cardinality of A equal to n and cardinality of A equal to n and cardinality of B equal to m. Then cardinality of A cross B equal to mn. Now if cardinality of any set is mn, then number of subsets of A cross B, then number of subsets of A cross B equal to 2 to the power m into n. This equal to the number of relation. This equal to number of relation from A to B. If we take the set A only, then we define relation in A, and if we take the set A and B distinct, then we define the relation A from A to B. Now, types of relation. Now, types of relation. First, identity relation. Let A be any set, then subset S of A cross A is called is called identity relation. Is called identity relation if S equal to the collection of all ordered pair of the type A comma A belongs to A. For all A belongs to A. Then the subset S of A cross A is called identity relation. Now second we know reflexive relation. Reflexive relation. Here we define, let A be any set. Let A be any set, then S, which is the subset of A cross A, is called reflexive relation. Is called reflexive relation in A if S contains I, where I is nothing but, if we denote identity relation by the term I, then we say it is identity relation, and reflexive relation is nothing but if A be any set, then S, which is the subset of A cross A, is called reflexive. It's called reflexive relation if identity contained in S. Now we define irreflexive relation. We define irreflexive relation. Third is irreflexive relation. Third is irreflexive relation. A subset S of A cross A is called irreflexive. If S intersection I equal to phi, means it has intersection with the identity relation is phi, or with identity relation it is disjoint set. Now here we observe that every identity relation is reflexive, but every reflexive relation need not be identity. We can see it by an example. Suppose if we take an example A, in which we can take two elements A and B, then A cross A contains AA, AB, BA and BB. Like this. If we choose a set S like that, AA, BB and B comma A, then it is reflexive. But not identity. But if we choose a relation like S1 in which AA and BB is only present, then it is identity relation as well as it is reflexive relation. So here we can write down the result. The result is every identity relation is reflexive, but converse need not be true. Converse need not. Now we know symmetric relation. Symmetric relation. A relation S, which is a subset of A cross A, is called symmetric. If AB belongs to S, implies BA also belongs to S. Then such a relation is called symmetric relation. Identity relation is symmetric. Note, we observe that identity relation is symmetric. Now we know transitive relation. transitive relation. To define transitive relation, set must contain at least three members. Otherwise, transitive relation automatically hold. Let S, which is a subset of A cross A, is called. Let S is a subset of A cross A. Then S is called transitive. Then S is called transitive if EB belongs to S, BC belongs to S, implies AC belongs to S. Implies AC belongs to S. Then such a relation is called transitive relation. Now, the very important term is equivalence relation. What is equivalence relation? If on a set equivalence relation hold, then we can do the partition of that set. It is the very most important application of mathematics. Equivalence relation. Equivalence relation. If S is a subset of A cross A, then S is called equivalence. Then S is called equivalence if first S is reflexive, second S is symmetric, and third S is transitive. Then we say relation is equivalence relation. Now the third term is function. With the help of relation we define function. Every relation need not be a function, but every function is a relation. Now, how we define a function? Function. Let A and B are two sets. Let A and B are two sets. Then relation S of from A to B is called function or mapping are called function if each element of A have unique image in B. Then we say the subset S is a function from A to B. We can define here, we can understand this with the help of like that. Let this is a set A and this is a set B. We suppose this is a gun and suppose it contains some bullet. We start this gun and continue till all the bullets is emitted from A and goes to B, and each bullet has a unique image in B. Means that if the bullet A reach at the point B, then it need not go to any other point at B. Similarly, the point A also, the second bullet also have a unique destination. So if each element of A, the very important is each element of A, means that each element of A must attach at the unique element of B. Then in such a case the relation becomes function. Now we see whether the equation of circle is a function or not. If we take the example, this is the equation of circle, x square plus y square equal to 1. This is the equation of circle with the center at origin and radius equal to 1. Now here, if we find the value of y, then we can find out the value of y equal to plus minus under root 1 minus x square. Means for a single value of x, we can find two value of y. Means that here y can be written as fx plus minus under root 1 minus x square.